So let's talk about why we care about this question of whether or not the class P is equal to the class NP. So there are a lot of problems out there where we have really good ways of verifying those problems, but we don't actually have good ways or efficient ways to solve those problems yet. So there are lots of problems that we have encountered that are very easy for us to check solutions, that is, those problems belong to the class NP. However, it's very difficult for us to have generated those solutions. That is, we don't know that those problems belong to this class P. And depending on how exactly this question ends up being answered, it could dramatically change how we actually go about studying computer science, what sorts of things we can and cannot do with computers. So, for example, if it turns out that P does equal NP, which means that every problem that can be efficiently verified can also be efficiently solved, then that means that we can do things like automatically prove theorems. So the way that we do math could change by a lot. We could also do things like predict protein folding. So if I have some sort of amino acid chain and I want to know the shape that that protein is going to have from that chain, then that is really easy for me to do if P does equal NP. So that could be used to do things like create enzymes to help with various manufacturing processes. So we could start using yeasts to manufacture more things by genetically coding the yeasts to produce certain enzymes. Or we could do things like make new treatments for various diseases by designing proteins that would directly bind to, let's say, some sort of virus's active site, thereby disabling that virus. So we might be able to cure viral diseases if we could do protein folding super efficiently. However, there are certain things we might want to do that it turns out we just can't do. We're not going to be able to do things like have cryptocurrencies. So cryptocurrencies like Bitcoin are just going to be impossible if P does equal NP. Also, we're not going to be able to do cryptography. So if P equals NP, there are lots of additional problems that we can solve that might be nice. If P doesn't equal NP, then some of the things that are really important in how we use computers and how our society is working aren't going to be possible either. So it's unclear whether it's good for P to equal NP or bad for P to equal NP, but we know that how it is that we use computers and how we build systems using these computers could change pretty dramatically depending on the answer to this P versus NP question, to this P equals NP question. And to give you an idea for just sort of where people, where experts sort of feel about this problem, what they think the response is going to be, there's actually been surveys that were conducted. So there was a survey that was conducted in 2002 of a bunch of expert theoretical computer scientists, another one in 2012. I think there's plans to do a third one in 2022 to see kind of how things might have changed. And here are some of the responses for what people have said about this. You can see that when the question was first asked in 2002, it was about 60% of people said that P did not equal NP, about 9% saying P does equal NP. In 2012, 83% now say P doesn't equal NP, with 9% saying P does equal NP. And basically, that change says that from 2002 to 2012, a lot of the people who said, I don't know, have sort of changed their minds to come to the conclusion that P doesn't equal NP. And the reason for this is essentially because of the relative difficulty in proving P does equal NP versus P doesn't equal NP. So the way that we're going to be approaching this problem, the way people are trying to answer this problem, is set up in such a way where in order to prove that P does equal NP, we can take one problem from some large collection of problems and just find some way of proving that problem can be solved in polynomial time. So what we're going to be talking about next is how it is people are trying to answer this question and why it is that it would be easier for us to prove P equals NP, provided that's true, compared to P does not equal NP, which is the reason that we have this drift from people saying, I don't know whether P equals NP, into saying P doesn't equal NP. Because the way that we're trying to approach this problem would make it much easier to prove does equal NP compared to P doesn't equal NP. So the more time that passes without us being able to resolve the question, the more likely it is that the question is going to be resolved, or that the true statement is the one that was the harder statement to prove. So in our next video, we're going to be talking about how people approach this problem and how it is that we're actually trying to solve it.